Yeah. Right. I can't seem to hear you. Testing. Could oh, what? Daniel, can you hear me? Yeah. If you're speaking, I cannot hear you. But your mic doesn't seem to receive any signal. If I look at the Zoom, maybe. Okay. All right. Sure.
Hello?
Yes. Now I can hear you.
All right, that's good.
Cool.
Okay, shall we get on with it?
Yep.
All right. We left off from 11.2, right?
11. Yeah. Did we cover?
Okay. Can you see my screen?
All right. Sure. All right. Yeah. Okay.
We stopped around here, right?
Okay.
If I'm not wrong. Yeah. Yeah. So, what's the purpose of the ion core?
Ion core. All right. So your question, right? Okay. Let me close this. Let me open this, and then let me go to page. Well. Okay. So without the core, transformer can do his job. And he will do his job with a lot of inefficiency. He doesn't. Could you go to the slide before? Let's see whether he give you the drawing or not. No. All right. Okay. No. Right. So I'll draw for you. All right. So my pen is here. Now, if you would look at your Jamboard also, yeah. Right. So the purpose of the core is very clear, and it has to be there, right? Okay. So so the core looks like this, huh? Right.
Yep.
In practice, the core seems touching, but a very important part is that since the wire is still insulated, so technically the core is not really touching the wire. This is very important. If the core is actually touching the wire, then the conduction will happen. Right, wire is insulated. So even though it looks like it's touching, the insulator is the one touching. So you cannot conduct, cannot conduct from primary to secondary. The one, okay, yeah? Also good, yeah?
Okay.
Now, what happens when you don't have the core? I'll just draw this way. Now, have you accepted already that coil is basically a magnet? So a magnet will have a magnetic field lines, right? We'll have the magnetic lines like this, like that, and like that. Okay. Let's say this is north and south, right? Because they always split. And then you see that there are very few lines which actually goes into the secondary coil. Like it or not, the majority of the lines. This gives you the impression that half the line goes into the secondary coil. In reality, it's even worse than that because the magnetic field line is, is a donut around the primary coil. So only a slice of that, donut is going into the secondary coil.
Mm.
So far, so good. Now, why is that important? Because only those field lines give a flux. Look, remember, flux is just a fancy word for the cross section that is penetrated by the field line. So obviously, this coil is only penetrated by very few field lines, right? And that makes it very inefficient. You are losing power simply by not having the full flux in your secondary coil. Do you understand this already or not?
Yes.
All right.
Understand.
All right. So how does the core help you? Now, the core has to be made out of iron, specifically soft iron. This is the only material that you should construct the soft core with, nothing else. Now, why? Because the soft iron or iron in general are magnetic material. So there are other magnetic materials, but soft iron is the cheapest and the best of all, right? So when you have soft core going from the first primary to the secondary, that's the point of the core. I go from primary to secondary. Suddenly, all the field lines are concentrated. All. And I really mean all. It's very weird. Suddenly, the magnets outside no longer respond. Whereas here, the magnets will respond. Suddenly, they no longer respond. The iron seems to absorb all the magnetic field lines. Now, that's not really true. It's more like it directs all the magnetic field lines. Now, the explanation like that already, now you already understand why. Okay, we can go more, but that's it lah, basically.
Okay.
Right. Why does soft iron core absorb? That's another discussion. They don't usually ask that, right? So if you're in a hurry, we don't have to talk about that.
Okay.
Right. Okay. Now, this is, however, important as part of your explanation. They will be very interested whether you know this or not. And so they will ask, and it's very predictable what the answer is.
The answer will be the soft iron core is made of a magnetic material which directs the magnetic field lines
into the secondary coil. Into the
secondary coil.
Increasing the effectiveness of the transformer. Okay, that's I suppose that's a very acceptable sentence. You will find those sentences in this various form in your slides. Because why? Because your teacher know that it's going to be in.
Into the secondary coil.
Yeah, that's the whole purpose, right? I want everything into the secondary coil.
Transformer more efficient. Okay. Okay. Yeah, this part, transformers.
So
E is what again?
The weird E, epsilon, is EMF. That means the EMF of the primary coil is not always equal to the voltage of the primary coil. Let me see whether he already, because there's a reason why he. Let me see. There's a reason why he mentioned it. Okay, there you go. So if we assume, right? If we assume that the resistance of the primary coil is negligible, that's not true, right? That's not true, right? But idealization makes our life easier in physics, right? So the EMF generated somehow by the generator, because the primary coil is connected to the generator, right? That's what the primary coil is connected to. Then if you assume this ideal world, then the EMF generated will be totally becoming the transformer primary voltage. And this is making your life easy. And I've never seen a question where this is not true. If they want to go realistic, that means the VP will be lower than EMF, right? That's realistic. Then they'll set up a circuit for you that you can calculate. Right? At this point, I'm assuming that your DC circuit is good. You just have to use voltage divider to find the real VP. But I seldom see questions do that in transformer. So this is a very weird page where it doesn't seem to be of any practical use because this is assumed. It's just assumed. I'm a bit confused why he dedicated one page for it. This is important, right? Efficiency is more important than the slide just now. So to be fair, transformers practically is close to 100%. That's because of the iron core. Is the iron core thing, that's all. Okay, an 80% transformer is garbage in practical work. Like it is almost 99.9, maybe 9, whatever lah. It's above 95%. It's above 95%. Right? Not the transfer, the coil. It's because of the iron core, the soft iron core. Right? It has heat loss a little bit. There's hysteresis. Yeah. Anyway, so even though the idea power loss is real transformer, right? So there they go. He wants you to talk about this. He wants you to talk about the why it is not 100%. He wants. And there goes two slides.
Eddy currents, hysteresis. Hysteresis? I understand this.
This hysteresis is a very fancy word for which one you want me to explain? The eddy current or the hysteresis?
Eddy current, I get.
Right. Now, how do you solve eddy current? That's what they want you to know. How do you solve it?
Use a laminated cell.
Right. Now, my question is, what's the direction of lamination? They sometimes test you that. It is not obvious one. It's not obvious one. Now, that's the coil. That's the coil. So look at your 3D picture at the bottom right. Now, you tell me the direction of the lamination of this coil, the core, because the core is not laminated here. All right, very good. If you laminate in any different way, that would be not helping. That would be not helping. Do you need to know? Do you need to know what? Oh, I'm being very practical. See, that's the direction. You see that? You see that? That's the you see the lamination. That lamination is how you will expect it, just like your picture. The coil is not visible because the coil is inside the wrap package. The wrap package is there to protect consumers. Okay, so hysteresis. Do you want
the soft metal core getting magnetized?
Yes.
And then there's energy needs to be used to demagnetize the core.
Because
the loss of efficiency.
Correct. AC goes back and forth now. So the way the soft iron core direct the magnetic field is by becoming magnet. This is the exact method how the soft iron core can concentrate, because he becomes magnet, then everything like that. Then you realize that every time AC go back, when you go back, first the iron core must neutralize, no longer a magnet, and then become magnet in the other way. That is the hysteresis law. That will cause the core to be hot to touch. Now, which is said here. This is the indication that some energy is lost. With the indication. That's all. You cannot prevent this because soft iron core, the word soft, is how you minimize hysteresis loss. Right? That means you're already minimizing it. Soft iron core, that means they will sometimes ask you, so why don't I use steel? Steel is not soft iron core. Steel is, I guess, hard iron core, right? Iron core. And hard iron core, the hysteresis loss is much more. Right? The soft iron core is already the best practical solution. Right? Cannot be avoided completely. So let me just correct that. Cannot be avoided completely. So you know where they're going with this. No formula, right? Almost no formulas. They're more interested in the details of the efficiency of the transformer. The formula is just like that. Yeah, nothing complicated. So ways of improving, laminating, right? Okay, to minimize the eddy current, right? And then this is already in the first slide. I don't know why they repeat this, right? And then choosing the core material, there you go, soft lah, right? Soft. So don't choose a hard one. Right. And now this is formula. This shouldn't be giving you any trouble. Now, the question gives you the impression that all the efficiency discussion is not important. No, they are more important than the formula. They ask more on that than the formula. Okay. Okay, so this slide.
No problem.
If you know that the power loss is I square R, then
This is all formula.
they never ask for the explanation. So
Okay.
they never.
This is P equals I square R, right? Power. Yeah.
Yeah. Because you will notice that P in some other cases can be interchangeable with V squared over R, right? V squared over R or VI. But in terms of calculating heat loss, only I square R, and they don't seem to explain why.
Yeah, there's two new things that is the rectifier and the capacitor.
Yeah.
Those are two things I haven't learned before.
Correct. Let's talk about rectification. Now, let me ask you a question so that you understand the practice. This whole topic is very practical. So it's nice to know the practical usage. So why would I even want my AC to become DC? I guess
house appliances.
Fancy or sophisticated house appliances. No? That means your fan is not sophisticated. That can handle AC very well. Your aircon, surprisingly, the aircon motor, definitely the aircon compressor, the one that makes it cold, is also not that sophisticated, can handle AC. In fact, they like AC a lot, right? Your fridge also AC. However, our phone, our laptop, all the other fancy stuff is cannot take AC, it will blow up. If you try to reverse it, things break down.
Okay.
So the small and the fancy sophisticated stuff deals with DC much better. The big, heavy, bulky, powerful stuff, AC. Okay. So we can only get AC from our wall, our socket wall. So your adapter of your laptop will do two things. It will first rectify. That's why your adapter to your laptop, your charger, basically, right? Your handphone and your laptop charger will say, I can receive AC, input AC, blah, 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 blah. Output DC. So your charger must be rectifying. Right. So this slide doesn't tell you much. Maybe we go to the next slide.
The half wave, full wave thing is a bit confusing.
The half wave is probably the easier way. So don't worry, very easy to understand. A rectifier sorry, fancy words. That thing is called a diode. A diode rectifies. So can you call a diode a rectifier? Yes, but rectifier is rectifier is the more general term. That thing is a diode, a more specific term, meaning to say you can rectify using other things, but they just don't discuss, right? So the diode's job is to rectify. That's one of its jobs, right? So call it a diode, not a rectifier. A rectifier is a general term. So far, so good, yeah? Now, what does a diode do? First thing for you?
Light.
Light emitting diode. All right, light emitting diode, LED is a diode, and that diode is already way over his original intention. That's not a bad thing. Like he developed so much, but the original intention of a diode being invented is to allow current in one direction only. The direction of the arrow, very simple, right? Look at this diode. The diode allows direction in which one? Which direction?
This direction.
Right, and therefore it doesn't allow the current in the other direction. So you cross the arrow to the other side. No, that is allowed. That is allowed because that arrow. Okay, that was not right. Okay. So that is the only explanation needed for your waveform. The other half disappeared. Because it is not allowed.
Why is it not allowed?
Because that's how diode works. Diode works like a one-way gate. You can only go in, you cannot go out. You can only go to the right, you cannot go to the left. But AC goes left, right, left, right, left, right, left, right. You have never seen a device which only allows one direction, is it? You have never seen that.
No.
Have you seen a device called a valve?
A what? Valve? Yeah.
V-A-L-V-E. A valve by nature only allows one direction. That's why it is called a valve. A one-way gate is a valve. A door is usually not one-way. For example, biology. Your heart has a valve. You might vaguely remember that.
Yeah, I know that.
That means your heart does not allow your direction of blood to reverse, which is very catastrophic to you. To me, as a human being, we cannot afford to reverse our flow of blood. And that can happen if you don't have a valve. Do you remember the shape of the valve? I'm going to draw for you. So let's pretend that this is your heart and this is what goes out. And a valve, if the direction I want to maintain is this, then the valve very easily will look like that. Now, here is the exact shape of our heart's valve. Okay, you have to refresh a bit. Yeah, just refreshing, just waiting for it. Okay, still not refreshing. I'm recalling something. Maybe you go in, go out. There you go. Now look, the valve in our heart and in our bloodstream looks exactly like this. And how does it open? Like that, lah. It opens like that, correct? When the flow goes like that, obviously it will open the valve, so no problem. Can you imagine what happens?
Backflow. Yeah,
correct.
I understand.
The shape matters. That's valve. Our valve is diode. Diode is valve. No? The shape of the diode is not exactly like this. I mean, we don't care about how it is shaped, but that diode is a valve. Therefore, the other direction is blocked. Therefore, your waveform just lost half of its power.
So it allows only half the waveform to go through.
Which is obviously not good, but better than blowing up certain things. Better lah. At least the other half has no potential of ruining our life earlier, right? Now, this halfway rectification shouldn't be discussed too much. You should go to full wave. So from half wave, you go to full wave first. That means how to recover the lost one, and then you capacitance the full wave, right? This is where capacitance is first introduced, and we will explain later. Let's ignore this slide for now. Okay, let's ignore this slide for now. Even the drawing is wrong, you see. I am very surprised that the waveform drawing is wrong. Okay, never mind. Okay, never mind. Okay. Yeah, that waveform is wrong. That waveform is wrong. It's really wrong. It's really wrong. This one is also wrong. Okay, this one is also wrong. Now, I want you to focus on the full wave rectification because that's the most complicated one you need to understand, right? Okay, and then I'm going to explain the full wave mistake, the drawing mistake. A bit surprised here. A bit surprised. Now, don't take my word there. Okay, maybe I'm wrong. Maybe I'm too full of myself. Why don't later you just check with your teacher nicely? Okay, just check with your teacher nicely. Right? Don't say that another teacher says so. Don't say that your tuition teacher says so. Just I'll tell you what to confirm with him. Yeah, later. Yeah, right. Because you want at least 2 sources to confirm that something is wrong. Now, the rectifier, the full wave rectifier's job is to recover the lost one. Okay. Recover the lost one. This is now flipped. That's the job of the full wave rectification. So far, so good. Look at your Jamboard. I'm sorry. Look at your Jamboard. Look at your Jamboard. The next page. I've drawn something here, so you wait for it. Go in, go out. Try to tick the top left and then go in. No. Yeah, no, this doesn't work. So like you go out, you go out and then you go in again. And you go to page 14 again. Yeah, see, it immediately works, right? Okay. So I am losing this one in half rectification, right? If I could flip it above, then nobody gets blown, and I'm happy. That's full wave rectification, recovering what is lost. So far, so good. Do you see how many diodes are here?
4.
So you need 4 diodes arranged in this whetstone bridge. Let's call this a bridge lah. The moment when he refers to a bridge, this is the bridge loop that he's referring to. This bridge allow you to recover all the waves. All right, so let's see how it works. You know that this is a transformer, right? So this is secondary. Okay. So let's just pretend that this whole big thing is the transformer. Let's just pretend that, okay? Transformer.
Is it not?
Because this is the secondary. Yeah, because he go and do pictures which are outside the syllabus, right? How come there are 2 coils? What is this? What is that? Or whatever. Let's just pretend that this is the normal transformer that you know, right? It is lah, it is, but it's more realistic form of transformer, and they don't explain it. Right? Let's what I'm trying to say is, let's pretend that your transformer is basically a battery, right? The way you should imagine transformer is a battery or power source. Did that make sense? Okay. Even though transformer doesn't provide you the power, I know, but transformer is always connected to a power source, right? So let's imagine this as a battery or power source. It's just that the battery is sometimes like that and then flip, and like that, and then flip again, and then like that. It's a very weird battery. It keeps flipping around. So far, so good. So far, so good. Okay, so this is position A and position B. Now, why am I doing this? Because I want you to see how he recovered position B. Position A, let me draw first. So let's say this is position A. So how will the current flow from the positive to the negative, right? So the current will flow like this, correct? So far, so good. Okay, I'm drawing something, correct? And then I am going to go through this direction. Good. Good. Good.
Can I just ask you like a theory?
Yes.
Because let's say, where is my? So this essentially is the half wave thing, right?
Yeah, that's halfway.
Because it only gets a half wave. Then the current continues up here, and then it comes back up. So this part gets the other half of the wave.
No. I'm trying to draw it. I'm trying to draw it. So position A, the first half, right? The position half, you must finish the circuit. You must go like that, and then go through this, and then go to the negative side. Remember, you go from positive terminal to negative terminal. Can you follow the first half first? That's the direction of the current. Can you follow that?
Okay.
Yeah, that's the right one. And you notice that therefore they don't use this diode. They don't use this diode and this diode, and it's totally fine. I still find my way back to the negative terminal. All right. Now I'm going to draw the blue lah. The blue is the half that we are supposed to recover. So first of all, the blue is positive below, right? So we go here, boom, right? We go here, and where do we go? Where do we go? At the junction Y?
Right.
Okay, good. Diode 2, right? Diode 2. And can we go to diode 1? No. Correct? We can't. Then we go here, look, force. Look. Oh my goodness. Look at that. Look at the direction of the 2 arrow in the resistor. Why is the resistor important? Because the resistor is where your stuff is. Stuff that needs power, that needs DC. Right? That's where it is. Arrow becomes the same. Fancy, right? Fancy stuff done by the bridge. That's the whole point, right? But only there, because after that, of course, he will go back here, and then he will go up, and then he will go to, at the junction, he will go to
negative
D3 or D4? D3 or D4?
D4.
D4, and then go here. That means the rest of the path, he is different from red, as it should be. But only at the most important junction, the stuff, the resistor, it is that's your full wave rectification. I'm not sure whether the next slide explains. He is supposed to explain this. Could you just check the next slide first, please? I'm a bit confused, right? Oh, he explained with words. He explained with words. Okay, you have the Jamboard, and I strongly wish right now that your Jamboard can add to your PDF, right? I strongly wish right now. Or you can draw yourself, which is nice. Raise it up, go to D3, right? Go to D3 and go to the negative terminal, right? That's your first half lah. Now draw your green first half. Whatever, right? Okay, good. That's the first half. Then the second half, use a different color. Yep, doing well. Yeah, you have achieved full wave rectification. Yeah, you did. Just have to go back. Wrong, wrong turn. Yeah, wrong turn. Yeah. Because you cannot go back to the positive, right? That's why, right? That's why. Just go to the negative. There you go. That is diode bridges achieving full wave rectification. So currently nothing is lost. Okay, now I will explain the capacitance thingy. Right? Without knowing how capacitance work, let me give you a very brief idea. Go back to the Jamboard.
Just one moment.
Okay, yes, do whatever you want. So the drawing here, although there's a capacitance lah, okay, but we are just talking about rectification. Right? We're just talking about rectification. We haven't actually talked about how capacitance work.
So no loss. Use of 4 diodes. What else?
And the layout, they will never ask you to draw the layout, so thank God. But at least know how the circuit works. At least know lah. When you see a 4 diode thing like this in a different setting in exam, right? They draw a different circuit. The first thing that comes to mind is, oh, this looks like that full wave thingy. Okay, let me figure out how the current works. The drawing in your exam might be different, right? Might be different. You don't have to memorize. I don't think the layout will be the same, right? And I will ask you to draw. Now, I will explain the capacitance. There is no need for the slide, right? So go to the Jamboard. Go to the Jamboard first. So without knowing how capacitance work, I'll explain what capacitance do. Page 14.
And 15.
Okay, right. Okay. Now, this slump, no, you're correct. 14. Okay, the slump in the middle. Okay, it's a 2 mountains, right? 2, 3, 4 mountains. So in between the mountain, you have a plunge of 0, right? Sensitive electronic equipment also don't like that. They don't like to be basically on off. It's still an on off for them because you dump the 0. So far so good. So they don't like it. They die if you do that like 60 times. Actually now it's 120 times per second, which is really bad for electronic equipment, very sensitive. Now, so a capacitance is very simple. A capacitance basically chop the mountain a little bit, chop and fill the valley a little bit. I'm drawing something. You go out and go in again. This is taking too long. Go out and go in. Yep, and go in again. Page 14. All right, see? All right. So what did I do? I chopped the mountain and fill the valley, basically. That's what a capacitance do. right? Let me chop again. Chop, fill, chop, fill, chop, fill. Now, how does a DC circuit, does the DC current look like? A DC current looks like this. A DC current looks very stable. This is DC, right? The green one is full wave rectified with capacitance smoothing. Capacitance smoothing. AC low. There. Slightly already very similar to a DC low without any wild too wild of a swing. Okay.
Okay. What are
So
capacitance?
I'm sorry?
What are capacitance?
He takes, I don't know, maybe 20 slides to explain it. So later lah. Now look at your slide that I say is wrong first. This is where I want you to confirm with your teacher. Go back to your slide. Go up. Okay, go down. There you go. Okay, here. Yeah. So you see the valley being filled, right? You see the valley being filled. Topping the mountain. That doesn't work. That's the issue I have with the picture. Same thing with the picture after this. You want to fill the valley, chop the mountain properly. Basically lah. That's how capacitor works anyway. Right. So if you use the word, how come the mountain is not chopped to fill the valley? He will see it as a very informal way of asking, not a very, fancy way lah, but it makes sense, right? Then maybe he will be able to accept what you're saying, and maybe he will be able to correct for the whole class, right? Okay, right. So I intentionally use a very informal way of saying it so that you don't appear like a smart aleck. Okay, I don't know how, I don't know how sensitive your physics teacher is. Right. Right. Okay, any questions so far before we go to 11.3?
Nope. Just not mention about capacitance.
Right. Okay.
Capacitors.
So we have 5 minutes. Let's go. Let's go to 11.3 and we'll continue again later.
So wait, what's the point of capacitor?
I just told you. The first, there are many uses, but the most important use that they tell you is just now lah. Chop mountain, fill valley lah. Make a smoother rectification to make it appear like a DC. That means you're trying to simulate DC from AC ma. So you have to again chop mountain, fill valley. Right? And capacitor is the best thing to do that really. It is very well designed for that.
Why don't you need to charge it up first? It's not instant.
Yes, and precisely that. So capacitance is a very easy thing to understand, right? Never mind all these things first, right? Just imagine an empty bottle. An empty bottle capturing water from the stream. Very simple, right? The current is flowing. You put capacitance. Doesn't matter about the parallel series. Like just never mind that for. The point is, if current flows into a capacitor, the capacitor works like a bottle, an empty bottle capturing the water, and after a while, obviously the bottle is full. So far so good?
Yeah.
Now, if you design the bottle correctly, that means you time the filling of the bottle. You can do that by just designing the capacitor. If you do that, immediately when the stream reverses, remember, in real life, stream don't reverse. But in the AC current, it reverses every time, go here, then go there, go here, go there. So far, so good? So when you go in one direction, the bottle fills until almost full. And then you reverse. And then when you go down and you reverse, the bottle had a chance to dump some water to the stream. That means the stream must dry first before reversing, correct? So the stream goes up, fill the bottle, dries before he goes to the other direction. When the stream dry, the bottle is almost full. That's how you time the capacitor. Can you imagine that? When the stream dry, the bottle dump water to the stream.
All at once.
Not at once, but just slowly. But again, you time it. So you dump to the stream, so the stream doesn't get too dry. That's how
So
you
it
top
stores
mountain.
the energy and then releases it. It stores the electricity.
Kind of,
releases it.
Release it, and then when
Releases
the
it in,
reverse,
like one steady waveform.
Yes, you chop, fill, chop, fill, chop, fill, chop, fill. That's what a capacitor do in AC.
How does it chop fill?
Then the chop means because you're taking some water from the stream. Unfortunately,
Yeah,
the stream is more like.
That?
Oh, let me show you. Let me show you. You're happy with the function of capacitors? Now let me show you. Right? Not here. No. You just go to 11.3. I'll just find a slide there quickly. Let's go down. Go down. Okay, here you go. I'm gonna show you. Capacitance is not instinctive in any way, right? So you just slowly understand, because thankfully it's not complicated at all. It's really not. It's really not complicated. It will challenge you with a preconception first. It will challenge you with a preconception. I'm gonna talk about that preconception, and then we'll probably have to end, right? Okay, unless your junior happen to come in, right? So I'm just going to use, I'm sorry, let's go to Jamboard, page 15. Okay, go out, go in again. Okay. This, we got it. Okay. Okay, just focus on this capacitance for a while, and let's ignore this two for a while. Huh? Let's ignore. Just pretend that they don't exist, right? So I'm going to close the switch. Okay, done. Going to close the switch. Right. Now you notice this is an empty space, right? Empty space. Now here's a challenge to your preconception. An empty space means it is not a closed circuit, right? It's not a completed circuit. Correct?
Yeah.
Can current flow in, well, such an open circuit?
I mean, yes, you ionize the air, technically you can, right?
Right. So when you ionize air, right? When you ionize air, the air become ion, or then ion conducts okay, then suddenly the air which is insulating becomes conducting. Then you can conduct load. Right. Unfortunately, that is not what is happening in capacitance. There is no ionizing involved. So we are not talking about lightning. We're not talking about lightning. There is no lightning going on between the two plates. It is really empty space filled with air. It is insulating. Again, can current flow like this?
No.
According to you.
Wait, yes.
How?
Wait, through empty space or what?
Empty space, which is not ionized. Is air, is vacuum, is insulated, whatever. That's not a conductor.
If it's vacuum, then cannot lah.
Okay. Let's pretend that it's vacuum. It's a vacuum, so nothing can be ionized. Can current flow or not?
No.
All right. You are wrong just for a split second. You are wrong just for a second, and then you're right for the rest of the universe. A capacitance is filled during the time that your statement is wrong. For a split second, your statement is wrong, and current does flow. And
where
then
does it flow to?
Let me explain. So here's the concept here. Electron, you know that by now that current flow is electron, right? So electron flows here, right? Electron flows from the negative side. So let me check my WhatsApp. Is there anything important? No. Okay, because sometimes I get WhatsApp from my students. So electron flow like this, and then electron flow into the positive terminal, right? That's how battery works in, correct? As long
Yeah.
as you give the positive terminal electron, as long as the negative terminal, nobody blocking the electron from exit, the battery will do its job. The battery will do its job. So electron goes here. During the split second that you are wrong, electron goes here and gets absorbed. That's where you fill your bottle, absorbed. It literally not disappear, like it's actually filling a bottle, but from another perspective, the electron simply disappear because it is being absorbed, right? And then
because this is an AC, then it keeps on happening constantly.
no. DC will do this also. Never mind. Don't bring AC in first. Don't. Just bring in DC for now. Just bring because in DC you are split second wrong, and after that you are correct. Then let's talk about AC after this. Now, here is another electron going out from the positive terminal going here. I give you two colors of electron to illustrate that the electron coming out is not the same as the electron going in. They are totally different. They are totally different.
Why is there an electron coming out?
Well, my question is, the plates. The plates is made. Interestingly, the plate is made of conductive material. The empty space is obviously not conductive. So the red plate and the black plate are conductive. Metal looks simple. Metal. Does metal have electron?
Yeah.
All right. So the electron, the blue one, which came out from the red plate, is just the electron from the metal, and then kena absorbed by the battery. Just keep it that way. And the black plate is capable of storing, absorbing some of the electron for a while. It's definitely capable. This is open circuit, but flowing current. For a split second, this happens.
Okay.
Right? Don't you see that what I draw is exactly what your teacher draw? Don't you see? He just never mentioned explicitly that the electron are two different electrons. They are two different electrons, I can guarantee you. Yeah, they are totally two different electrons. So 1000 go here, 1000 go there, 1000 go here, 1000 go there. And what happened for a split second, the bottle fills up. This happened quite quickly in terms of microsecond, maybe 3 microsecond, 4 microsecond. How do we know? Never mind, they don't cover here.
Okay.
Right, so this is current flowing and filling the bottle. Once the bottle is full for a split second, your slides say charging finish, right? I say bottle is full, and the moment bottle is full, your sentence becomes correct again. This is now officially an open circuit where no current can flow. Officially, this is DC, by the way, because battery. For a split second, you are wrong, and that is how capacitor works. And then after that, capacitor not stop working, just capacitor is full, and therefore your sentence is now correct. Okay, your senior, your junior is not here, so do you mind if we just continue?
Sure.
Right, you don't seem too tired though, so that's good. Right.
Yeah,
okay.
I've been home the entire today.
That's a change. Good. That's good.
I'm on MC.
That's not good, right? That's not good.
Yeah.
Right. 3 of my students are sick, including me. Take care. Now, are you sure you want me to continue?
Sure.
Right.
I would love to learn more about this subject.
Right. So DC, right? DC, your bottle is full, no current. Please state that clearly in your slide. There is no more current. No more current.
DC. Okay.
Now, so this is your open circuit, which nothing flows, and you're correct. Now, I will explain a little bit why it doesn't flow, because then I can go to AC. Okay, now I'm going to AC. So here's the start. Now, if the battery is 9 volt, so this is 9 volt positive, and this is therefore 0 volt. Okay, let's imagine that way. So far, so good. When the capacitance finish charging, it mirrors this completely. This is your 9 volt positive, and this is your 0. Still, even though this is supposed to be negatively charged, right? Because we randomly decide that this is 0, this will become 0, this is 9, this will become 9. Right? I'm sorry for the confusion. I'm going very fast. So far, so good? If this is 9 volt and this is 9 volt, no current can flow. If this is 0 volt and 0 volt, no current can flow. Because no current can flow from 0 to 0. Correct.
Okay.
For charging, there is a potential difference. Then, finish charging when you no longer have potential difference. Keep it simple. Okay, so the capacitor basically prevent the current from flowing when it is full. Okay, so far so good. Now this happens around, let's say, 4 microseconds, right? I'm quoting a standard value, like 4 microseconds. Okay, that's why for a split second, you are wrong. Okay, now this is no longer DC, this is AC. Ready? So now this is AC. What happens in AC? You go from, very small voltage to very big voltage, and then you go back to small, and then you go back to big, correct?
Yeah.
So small, big, small, big. So what happened? Then suddenly the AC, let's say AC goes from 0 volt to 9 volt. And then he goes back to 0 volt. So he only goes to 9 volt for a while, just for a while. And then he drops back to, let's say, at 4 volt. Well, what happens at 4 volt? What happens at 4 volt is that the bottle dumps its charge. The bottle dumps its charge. Simple, right? Because now, because it's not 9 volt versus 9 volt, it's 9 volt versus 4 volt. Because AC does that. AC just lowers voltage and then up its voltage and then lowers voltage and then up its voltage. Right? Simple. So the capacitor will dump when the battery is not strong enough to oppose. The battery being an AC battery, which flips and drops and out. That's it. That's how you chop the mountain, and in this case, feel the valley. When the 4 volt is weak, 3 volt, 2 volt, that's weak, right? That's weak. The capacitor has an opportunity to dump its charge and create more current when the current is less, because the voltage of the the power source is less. Dump. And since the bottle dump, when the AC picks up again, right? Because AC will always, go down and then picks up. When the AC picks up again, the bottle fills again. And then when the AC goes down, the bottle dumps again. Dump, pick, dump, pick, dump, pick. Suddenly, our sentence is totally wrong all the time in AC. Because if we time the capacitance correctly, it will never be totally full and it will never be totally empty. Therefore, we smooth the current. Is that a mouthful? I'm explaining it in a very quick way.
Yes, it is. It goes between 9 and 0, like it swings between 90, 90, 90.
To be fair, that's the AC, right? The AC swings from 0 and 9. To be fair, the capacitor will never reach 9. No? He'll probably reach 7.5, kind of.
Because when it's trying to reach 9, then it switches to 0, so then it goes down, then it goes up, it goes down, up, down.
Right, correct. Because he doesn't do it instantly, remember? When the battery is like full charge, 9 volt, the capacitor is still filling up to 7.5. Hey, but then you drop. Then I follow drop, something like that. To be fair.
But wait, doesn't the AC, like the switching of current, it takes place like very, very, very quickly, right? Like milliseconds.
And that's why I told you the capacitor also works very fast. So 60 hertz, right? 60 hertz, right? The AC switches 60 hertz, right? In fact, because of the rectification, remember the rectification? By right, he's supposed to go to minus 9 volt, remember? By right, right? Oh, goodness me. We're waiting for my writing again. Could you please refresh? Could you please refresh? Go out, go in. Go back. All right, so by right, without rectification, I'm supposed to go from 0 volt to minus 9 volt, correct? By right lah. But now because of rectification, suddenly I go to 9 volt instead of minus 9 volt, correct? That's what you understand. So instead of 60 hertz, this is 60 hertz, right? You will flip to this 60 hertz. Then suddenly is 60 hertz times 2. So now this is 120 hertz. So this will flip every second 120 times. 0909090. All right, it's now very, very fast. So far so good? Very, very fast. Twice as fast because of the rectification. So far so good?
Yep.
1/120 second is, I don't know, we calculate. I think that's around 8 milliseconds. Would you help me? Would you help me with that? Is that 8 milliseconds? Using a calculator or something. Okay, 8 milliseconds. So I do this up and down 8 milliseconds, 8 milliseconds, right? So the bottle should fill not in 4 milliseconds. No, the bottle should fill in around 10 milliseconds. I should design my bottle to fill completely in 10 milliseconds because I flip every 8 milliseconds. Why? Because I don't want my bottle to be full before 8 milliseconds. If it is full before 8 milliseconds, my current is completely cut off. I don't want that. Am I making any sense?
Yeah.
Right. So I just want my bottle to be almost full before I switch. Then my bottle can dump. Before my bottle dump everything, I already go up again. Then I work quite well with this bottle. I don't want a bottle which is too small, basically, because 4 milliseconds implies that it is quite small. I just enlarge the bottle a little bit. Then you can take more. Then you can dump more.
So just get a bigger bottle.
Yeah, basically just like that. It's that simple for a capacitance. I'll just get a bigger capacitance. So, tada, finish. If not, the capacitance will cut the current because it fills too quickly. It fills too quickly. And that's not what we want. We want to smoothen the current, not cut the current. Now, I doubt you will discuss until the 8 millisecond, 10 millisecond thing. I doubt. But, I'm trying to explain how the capacitance work. Then we can go on to your slide and see what happened. Now, any questions so far before we go to your slide?
No.
All right. Kakak Brian, I see you, yeah. Just saying that today will be quite empty because most of the students are sick. It's very weird, yeah. 3 students are sick. So we'll just wait lah. I'm explaining to Daniel, but Daniel is JC2, right? So just take a peek if you want, right? Okay. Okay, so Daniel, if you want to continue, let's go to your slide and see what the slide talks about lah. Okay, so hopefully you have some understanding of this. Now you see the next slide, see whether it now makes some sense.
Can you just help me fill in the AC part again?
The AC goes from
AC.
The AC goes in a peak form, right? A peak valley, right? Then you rectify AC means you go from 090909090, right? There's no negative lah, right?
That's it. It just gets rectified.
Right, let's pretend it's 09090. So in 8 milliseconds, right? 090, 8 milliseconds. So your bottle is around 10 milliseconds, then your bottle will be almost full, then dump, almost full, dump, almost full, dump. You get your smoothening, you get your smoothening.
If you did discharge.
Yeah, discharge, then discharge. And then fill, and then discharge, which is discharge, charge, discharge, charge, discharge, charge. The bottle don't mind doing that, and we don't mind receiving its benefit.
Okay.
Right. So let's see whether this slide is actually talking about what I talked to you. I can
vacuum.
Blah, 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 blah. Blah, 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 blah. Right. So the point is, it's an insulator, right? In the middle, there's no conductor. Okay. So the next two paragraph, when the switch is closed, electron begins to flow. No surprise there. There's no current between the plate. I told you that, right? Electrons are removed from the plate connected to the positive. That's the different electron, right?
Yep.
Right.
Yeah, I'm kind of confused. How is it discharged again? Is it discharges from these two?
Okay,
and it
so
discharges outwards.
Right. So one more time. This slide doesn't explain the discharging, by the way. I go and explain the discharging. No, not yet. But it's very easy to imagine the discharging because imagine the capacitor is a battery. Remember what a battery is? The battery has 9-volt terminal in one end and 0-volt terminal at the other end. That's what a battery is. Okay, the capacitor is a battery. What? 9-volt, 0-volt. The capacitor is a battery for a while. So the capacitor has the ability to basically discharge electron because it is a battery for a while.
Let's say for an instant.
Or because the difference between battery and capacitor is when capacitor discharge, his voltage drop very quickly. A battery does not do that. That's why he's a battery for a while, because he spent himself very quickly. A battery does not do that very quickly. That's all.
It's a fake battery.
A very short-term battery. That's a very good imagination of capacitor. It's a very short battery which you can charge, discharge, charge, discharge. It's a very useless power bank to you. Just charge very and discharge very little. But turns out very useful for rectification. Very useful. Not useful for us. Useful for the AC to DC. Yeah, a very useless power bank for us. Now, your junior is here, so I would like to, maybe you take a break first and then we'll continue later in half an hour, right? At 9, maybe 9:30 9:30 for half an hour, right?
9:30. All right, can.
I'll see you then, right? Bye. Right, Ainesh, I can see you. Can you hear me?
Yeah.
Wonderful. Right, I'll video, right?
Yeah, sorry.
Did Arya ask to borrow your phone holder today?
My what?
Your brother, Arya.
Yeah, he asked to do what?
To borrow your phone holder, for doing tuition.
You mean the phone stand?
Yeah.
Oh yeah, he was using my table. I was helping him set up.
But he didn't show up in the tuition after. Why am I asking you this? Because last time we meet on Sunday, right? He is still deciding between Tuesday and Thursday. So there is no answer until today. So I was just waiting. Is Arya going to show up today or not? So are you saying
I can ask him right now if he wants. He's at home.
Can you ask for a while? Yeah, if there's a decision. Right? Okay, thanks.
Ruben, can you come here? Teacher wants to talk to you. Can you come here?
Hello, teacher.
Yeah, how are you?
I'm good.
Good. Just asking you one question. Have you had a decision to do it on Tuesday or Thursday?
My parents haven't decided yet.
All right. Then I will assume that today there is no lesson with you, correct? Yeah.
Yeah.
All right. Very good. Okay. If there is a decision, do tell me tomorrow or at least on Thursday, so I will know.
Okay.
All right. See you, Arya.
See you.
Okay. All right. Thank you, Ainesh. Right. Let's do our 45 minutes. Okay. Now, quick update on AMAT. By the way, your video on time is getting better and better. Yeah. Updates, please.
No updates. I haven't gone to school today.
So to yesterday and today, no school yet.
Yeah,
Understand.
I'm still sick, but because I'm missing out on too much in school, I'm gonna go tomorrow. And if I can't take it, I'll just come back.
Right. Let's do our best to make up for it, right? Because you are expecting the AMAT to be on differentiation, so you are not behind.
It's not.
But
My friend said that they finished partial fractions today. So if we continue differentiation today, we'll just be pulling further ahead of them. So I don't mind doing that.
understand. However, you may be more concerned with other subjects. I don't think AMAT is your biggest concern right now. Probably not. Probably more chemistry and physics, I will argue. Probably.
Yeah.
Okay, understand. Now I'm going to show you something very quickly. Gonna on my video, right, a bit. So can you see my video for
Okay, I can see it now, but I'm
Okay.
using the phone.
Right, no problem. Right, you don't need to be so. So I'm trying a new device for this year, right? So it will be this. All right, this has the same function as a phone holder, except that this is a camera already. This camera is connected to your laptop, right? So is your laptop Windows or Apple?
Windows.
Very good. So this only works with Windows. So the reason why I want to switch to this is because I always have a difficulty with the phone holder. It serves its function well, but it doesn't have this. Okay, so this is a map, right? In this map, goodness me, right? So you cannot see. So there are indicators here that allows you to align your paper, right? So this is the thing that I want the most. So you align your paper, and your paper will appear not slanted in my video, no matter what. When your writing is slanted, that's not your fault, right? The paper is slanted with respect to your phone, right? It's very difficult to keep it aligned. This and this should keep it more aligned, then I can screenshot your working much easier. That's the point. Okay?
Okay.
Easy to set up. So when it arrives to you, either you or Arya is going to use it, right?
Hi.
Okay, so no surprises. I also send you some sort of laptop holder, a small one, so that you can put your laptop in front of you. That is also going to be easier. That one should arrive soon. Okay, that's it. Right. Okay, right. So we're supposed to discuss AMAT, and we don't talk about partial fraction, right? However, there is no hurry in talking about differentiation because I promise you that you're around 3 weeks ahead of the class. Promise you 3 weeks.
Okay.
Maybe 2.5, depending on how fast your teacher is, right? Maybe 2.5 or 3, right? So let's strategize a little bit, right? The first strategy I want to do to you today is organizing, right? So I hope you are a bit at peace that we are not discussing differentiation, right? Have a little confidence in our holiday session. Okay, you'll be fine. Right? You'll be fine. Now, what do you mean by organization? So I have a few assumptions. You tell me whether I'm right or wrong. Okay, so rather than physical organization, you may like digital organization more. Correct or not? What do you think?
I do prefer digital organization.
Right, then let's do digital organization. Digital organization is very simple. It's very simple. We just use PDF. PDF is something you know already. That means from Jamboard to PDF. It's a very simple one-click button. We do that for all your Jamboard, and we file properly in that PDF, and then the PDF should be searchable. Then it will help you in the 2 weeks, 3 weeks, 1 week before exam. That is the point of organization from my point of view. Right? So a few things. The only reason why I want you to organize is so that your life is easier near exam. That's what I'm trying to think. What do you think about that?
Actually, I don't think I can hear you very clearly from there. Let me try something. Okay, I'm gonna use
Because-
my laptop to hear you and use my phone mic to speak to you.
Right, because today you're very clear. So I am not clear today, right? It's very weird. Okay, try that. Let's fix this problem. Today we have time.
Hello.
I can hear you loud. There's an echo. So you may want to disconnect them. Oh, you can't. Try speaking again.
Okay, is there an echo now?
No, it's fine. Can you hear me better? Can you hear me better?
No, there was an echo on my side. I have to leave.
Let me try
There's an
something
echo
else.
on
Then.
my side. So
Let me try something. Let me try something else. All right, testing Ainesh. Can you hear me? Ainesh?
yeah,
Right. Is it better in some way?
I think it's just always gonna be bad because, but it's okay. I can take it. It's not that bad.
Okay. All right. Yeah. Okay. If you cannot hear me, just tell. Okay. Because you're ahead at differentiation, we have time to troubleshoot all this problem because all this problem matters. It's not convenient nor is it healthy. Okay. Right. I still have hope that we can troubleshoot and finish this problem because other students don't have this problem, meaning it is a problem that can be solved. It should be able to be solved. All right, Ainesh? Right?
Yeah,
So
yeah.
we don't bear with such technical problem. If possible, we don't do that. We try to solve it, right? Okay, so again, can you hear me right now? Is it okay?
Yeah.
Right. Kakak Brian, I'm trying organization. So that's the second part of the hint system. So the hint system we organize. I'm just addressing my Kakak Brian, which is, you know who's Kakak Brian. Okay. So I think this is the first demonstration of organization. Do watch closely and see whether you can do it for the other students. Because I think I want to dedicate a time for organizing at the end of tuition every time, like around 3 to 5 minutes. And this is a very simple form of organization. Okay. Some students don't need this, but some students will benefit greatly. Right. So we'll just standardize anyway. It shouldn't take a long time. Right. Okay, so Ainesh, to do this, instead you're going to share your screen. We're going to organize. Share your screen and open the Jamboard. Just the latest Jamboard will do.
Let me see my screenshot.
Yeah. All right. So this is electrolysis, which is good. Well, let's just use this one for now, right? Because there's only one page. We'll use as a practice. Now, before you do that, I need you to install an app called, because you're Windows, right? So you click you press your window button. You know what's your window? No, that's not a window button. The window button is in your keyboard, the four squares.
Yeah.
That's
Okay,
all
okay.
window button.
You can't see, but I pressed it.
Oh, okay. Then you type your store, then you go to basically the Windows Store, right?
Yeah, Microsoft Store.
Okay, in Microsoft Store, you type Xodo, Xodo. That's the app that I know which is powerful enough. Xodo. That's a PDF app. Once you found it, please install it for a while. You will be using it.
Xodo.
Yes, Xodo. Xodo.
Okay, I've got it.
All right, if you got it, then install it. Okay, a little quick, right? Now, while waiting for it to be stored, let's try saving your Jamboard, this one page, into a PDF, right? Okay. So would you please click the triple dot on the top right of the Jamboard? All right. All right, then you can download as PDF, right? So do that, right?
I don't think the app is downloaded.
The PDF is not downloaded, isn't it? The
No,
app
no,
is
the
also not downloaded.
PDF.
The PDF is downloaded. Oh, there you go. Okay, so you open first. You'll be opening using your there you go. So this is a P. How come the ratio is very weird? Oh,
Yeah.
there you go. Okay, okay. I don't know. Oh, it's there. It's there. So make it smaller a bit. Maybe you make it a bit smaller, or fit window or something like that. Make it smaller. Okay, okay. So you can see that it's it's a full page, correct? A full page.
Yeah.
So what you want to do is open this PDF using the sudo.
I don't have that. How do I do it?
Yeah. Well, the sudo should be found in your Windows. Take care and drink.
Oh, I got it. PDF reader by Zodo.
Okay, Zodo, right. So I want you to open this PDF in Zodo, and I want you to show me the Zodo screen also, because I think you just share your Chrome screen then I want you to share the PDF screen also right? Right.
Can you see my screen?
Yes. Okay. This is Zodo, definitely. Now, can you open the PDF using this somehow? You go and find it, right? Okay. So let's say that one, right? Okay. All right. Very good. Right. Okay. Okay. So we're going to go back to your Jamboard. We're going to your Jamboard. Right. I'm going to show you what it means by organizing here, because organizing is not about making Jamboard to PDF. That's a downgrade. Why would I want to make my Jamboard into PDF? That means you cannot edit the Jamboard anymore. That's not an upgrade. So there are reasons why you want to do this. Now you go to your math PDF, for example. This is an example.
Math PDF.
Correct. Math PDF, math Jamboard, because today is supposed to be math, right? So you go to math PDF.
What's this?
The template testing. Template testing, never mind. Oh, can we use this? Okay, let's try to use this. Okay, let's try to use this. So again, save to PDF. The triple dot on top, right? Download as PDF. Download. Okay. Once you're done, go back to your sudo and open that new PDF.
What's this?
System viewer currently is not sudo so that's not going to help you too much. Unless you set the system viewer as sudo, then that will help you right? Okay, so okay, it's a bit complicated, I know, but this is the app which is powerful enough to do what we want, right? So can you open both PDF, right, using sudo? Both PDF.
I opened the earlier one. I'll open this one now. The Irish template testing. How do I do this?
Browse. Yeah, browse. Browse will be great. Yeah, browse will be great. So now, yeah, see, now you have the two PDF open in the sudo, right? So make it full screen. Maximize it. Right. So the first thing first is you can combine the two PDF. You can combine the two PDF very easily using sudo. That's the first target. Without that, we lose the ability to file as you grow your Jamboard. That means we're gonna, every time Jamboard, we go to PDF, we're gonna add it to this PDF in a very filing method. Okay, this topic, that topic. That's our first level of organization. So to do that, I'm gonna ask you to help me allow annotation so I can help you.
I can annotate.
You can annotate, and therefore can I annotate? How come I cannot annotate? Wait, how come I cannot annotate? Can you allow me to annotate? Because you're a screen sharer, you have to allow me somehow in the menu. Like you find your Zoom menu and allow annotation by participant or something.
Oh yeah, that.
Okay, now let's see. Okay, annotation. Can I? Yes, I can annotate. Thank you very much. So now both of us can annotate. How about using Green? So there are a few ways to add. My favorite way is, let's say I want to add the second to the first, right? So you open the first one first. Open the first one. right? And then you click outline. Click outline. Right, so in outline, yes, you have thumbnails, right? So thumbnails is a nice way to work. Now you go to the second one, you should be able to see the thumbnail also. Second PDF, right? Just go to, just click that. See a thumbnail also. So let's say you want to copy the second page only. Just pretend. Right? So you click on the thumbnail of the second page, right? Just click that. Click that and click first. Okay, then Control C for copy, Control C, done. Right. Go back to the first PDF and then try to Control V. Try to Control V. Let's see whether that works in this version of Zoho. Does anything happen?
Yes, no.
Right. Okay. Then that means. So you're going to do it slightly differently. You go to. Wait a minute. Where's the ad? Sorry. Let me find out where's the menu. Wait. Oh, this app is at the same time is very powerful, and at the same time is also cannot edit. You will go to edit page. Okay, now I know it. So I found the menu. So I'm going back to you. Right? So what you do is you go to this triple button, right? Triple dot. Go to triple dot. And then you see edit page. That's what you want. Edit page. You click that. Okay, now you're in the real thumbnail mode. This is a better one. You press Control C. Press Control C.
Control. Oh my God.
No, you don't click that. You don't click that because you already open it. Oh yeah. Edit page. Edit page. Just Control C, you know.
Yes.
Okay, Control C and then go back. That means you just click on it. And then go to the second one. Try copying in the thumbnail. If not, then you edit page also. Okay, edit page, then Control V. Paste here.
Oh, okay.
Does it work?
No.
No, that's not how you. Okay. But yeah, that's why I've been avoiding to teach this. Okay, let me just confirm that it works in my side. Right? Okay, just confirm first. I keep. It's natural for me to do this, so sometimes I forget. Right? Isn't there a better way to do this? Currently, I don't. Right? Oh, goodness me. Now I remember. I'm sorry, yeah? I'm teaching you the wrong way, yeah? Right, so go to the first one. The first PDF, right? Go to edit page. Edit page means the triple dot. Right. My mistake is try to call edit page, right? Edit page. No, edit page. Edit page. Edit page.
This one. You have to do this one.
Yeah, edit page. Yeah, okay. Now my mistake is to teach you that. Just forget about what I taught. Just go to plus. Let's go to plus.
Oh, it's gone.
Press the plus. No, press the plus. No. Here, this plus. Look at my annotation.
Oh, that was a teacher.
So does my annotation not show? It
doesn't.
Okay, click the plus. Okay, now insert PDF. That's what we want, right? Insert PDF. You're gonna insert PDF. Go ahead, right? And then you're gonna insert the second PDF. That will be a better way. So that will be your NH template testing, right? Click that. That's your second PDF, right?
Yeah.
Right. So this is your most basic filing. Look, filing means you're putting a note like a paper combined with other paper. That's what filing means. Right? Filing is not separating, filing is combining. Now you just finish your combination. So far, so good? Right?
Yeah.
So at this filing, we are still at this page. This page is very powerful because first of all, okay, let's delete this page. You can do that. Please try that. Please delete the page.
Okay.
Let's try deleting it. It's very easy. No, not 2 pages. No. When you hover on the okay. When you hover on the page, you have a trash can. That's the easiest way to delete one page, right? Try doing that and then undo again. Let's say you mistakenly delete this page. Can you undo? Can you do that?
Nope.
You
Control
cannot undo,
Z.
really?
Control Z is all.
Really? You cannot undo, really?
Yeah.
I mean, you always have the original PDF, so that's okay. I'm a bit surprised here. Really? Okay, never mind. So you want to delete that page anyway. The second thing you can do is drag and drop. So let's say you want to move this page into the behind because your organization is math then chem, for example. Please try that. You just drag it and drop it there. There you go. Nice, right? Nice. Secondly, thirdly, you want to add an empty page between math and chem. You can do that also here. Please try to do that, which is here, which is at the plus sign. No?
So you cut up. What do you say? Hello.
Add an empty page in between, right? Okay, so add page, add page.
Done.
Okay, and then the page is there. Just move it, Just move it in between math and chem. Simple, right? Please do that. Okay, done, right? So as you can tell, you can organize yourself digitally this way. Look, this is your pieces of paper. You can just move around and file according to what you want. Make sense?
Yeah.
Right. So next time, I'm not saying that you should combine math and chem. I think you should not combine math and chem, but this is just for illustration purposes. So today we discuss a lot of math. You add the PDF and you naturally, where would you put your new pages? If you add more math pages today, where would you put them? Where would you file them? That's called filing. That's called organization. Where would you file them?
I don't know.
Really? Okay, let's try that. Okay, let's go to Jamboard, which contains your partial fraction, right? That would be which one? Let me see. Okay, let's go to your Jamboard and let's find the Jamboard which have that would be 10-1 math, right? Go to Jamboard 10-1 math 10-1 math. I think there you go. Yeah, that one 10-1 math. Yep, that's the partial fraction one, right? Okay, that's the partial fraction one. Now remember, this is your Jamboard, right? This is your Jamboard. So you have the authority. You don't have to ask me permission to delete and how do I say add stuff, right? For example, these icons are useless to you, right? So would you please delete them because they're not useful at all, right? That's just my suggestion. If you like them, you can keep them. I don't find them to be particularly useful for you now. Right? So delete, just use the delete button very quickly. Delete. Right? So you're cleaning this up before organization. Go to page 2. Is there anything else that you want to delete in page 2? Anything you want to delete? Right? And delete that. Right? Okay. Right. Go. Okay. Anything you want to delete here?
No. What's this?
Okay. Is this a useful page for you? Page 3 and page 4 and page 5. Are they useful? Then delete. Bam, 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 go. Okay, now export these 3 pages, please. Download as PDF. Right, you're done. And then try to organize. Please combine this PDF to here. How do you do that? Right? How would you do that? Kakak Brian, can you follow all this? Kakak Brian.
Roughly.
All right. I'm like this. Oh, Aditya. Now I see you, Aditya. I've been waiting for you. I didn't realize that you're there, Aditya. Aditya, can you hear me? Right. Okay. So Aditya, sorry, I didn't realize that you're here. Right. When were you here?
I was here by like 8:45.
Oh, right. We started at around 8:40. That's why. And we're discussing organization today. Now, have you been following the screen? The screen.
Yeah.
Right. Okay. I would like to dedicate the last 5 minutes to organize this starting this year because I find that to be extremely useful near exam, right? So especially useful for if you don't have your own method of organization. So Aditya, do you have your own method of organization which you are very satisfied with?
Organization such as,
For example, we're going to discuss a lot of complicated math concepts starting this year. Confirm one, confirm. And because you didn't follow the holiday tuition too much, so you have a lot to catch up. Now, the problem with discussing a lot of things is that at exam, you don't necessarily know where they are or know how to revise, right? So organization, what I mean by organization is as simple as we have to organize so that near exam, we know how to find things quickly and we don't lose anything. That's all I mean. And what I mean by what you should organize is just our Jamboard. So our Jamboard is not gonna be separate already. We're gonna combine them in a very good way, such that 2 weeks before exam, you can find whatever you want. You don't have to go and search for them. This is not useful if you're a very tidy person. It's not. You just ignore this today. But if you're not the tidiest person on earth, then what I'm going to do with you and Ainesh should be quite useful near exam. Right. So that's a summary of what we're trying to do right now. Okay.
So actually, like all our previous Jamboard, I like grouped them according to topic and I copied them down in a notebook for myself.
So you transfer it to a physical form, right? A physical.
Yeah, according to topic.
So in that sense that you are organizing yourself and you are quite a good one in organizing if you find it useful, right? So can you delete the Jamboard? Are you satisfied with your transfer of Jamboard to physical paper?
Well, I'm satisfied, but like I am not done yet. Like I only there's like 6 Jamboards, I think.
Correct.
I only just started.
Correct. I understand what you're saying, right? Now, if you have time to do all that, then good for you. This method that I'm doing is for people who might not have the time. For example, Ainesh very busy, right? Very busy. So this is like 3 minutes, 5 minutes every tuition. We file them digitally. Obviously, this is not a transfer from Jamboard to physical. We're going to file them in a form of PDF and going to file them per topic. Exactly what you want to do. That's just a natural thing to do. Right? So I'm just showing Ainesh and therefore you the software which is powerful enough to do that easily. This is the Sodo app. Okay. So Aditya, you follow for a while. So I'm in the middle of asking Ainesh to file 2-3 different Jamboard into one thing. Now, okay. So Ainesh, if you would continue, please combine the partial fraction pages into this PDF. You have to go to edit pages every time. Edit page, right? Edit page. And what do you do here? To add the third PDF, you will do that. Good. The PDF. Okay, that would be that. You have 3 things. And how would you like to, order them, organize them? No, don't go out from here. Adding the PDF is not organization. That's just combination. Okay.
Oh, there you go. I deleted the chem and now this is math.
Fair enough. Now, would you like to have the empty pages in between?
Yeah.
No, don't go out. Don't go out. There is no point in going out. Why? Because in the edit page 1, you can see everything anyway. This is where you want to be if you're organizing, right? So, are you satisfied with the order right now? Naturally, are you satisfied with your order, Ainesh?
Yeah, sure.
All right. Do you want to delete the empty pages between them?
No.
No. All right. Then I will say add another empty page between 4 and 5. I would say that. Do you know why?
There's an empty page between 4 and 5. Where is it?
I would suggest to you for organization purpose, add an empty page between 4 and 5. Do you know why?
No.
Because 4 is a different topic from 5.
Okay, sure.
Can you see that? Wait. Sorry. I really mean that. Like, can you see that 4 and 5 is a different topic just from this layout? Can you see that?
No, I'll have to go and see.
Oh, that's why. This is a common occurrence. I understand your Jamboard more than you. Okay. Could you see that page 4 is a different topic from page 6? Could you please see that? In the large screen, just click on them. Just click on them. Look at 4. This is topic, and this is
Yeah,
obviously not the same topic, right? Obviously, they are not the same topic, right? So
Yeah.
physically, it makes sense to put a border between them. So digitally, you put a border in the form of white pages. So far, so good?
Yeah.
Right? We'll go one step further so you can search very effectively, because if you do this filing, it will soon grow to a lot of pages, maybe 100 pages, maybe 200 pages after a while. Make sense? Right? So we must add another level of organization. Very simple stuff, but like the physical stuff, we have tag. So now please go to page 1. Go to page 1. Go to page 1. You click page 1 first. And then here, Aditya, Ainesh, and Kakak Brian, there is the second thing to use. So what is this? Let's look at this. What is this? Hover at it, Ainesh. Hover at it. Ainesh, go there. Right, go there. Yeah, that's bookmark. Go and add bookmark. Now, place in page 1, rename it not as page 1, but rename it as the topic of page 1. What is the topic of page 1? What is this? Partial fraction. Good. Then go to page 4. What is that topic, right? Because page 4 is the... How do you go to page 4? You can go back here first to the thumbnail and then go quickly, right? I switch between them, right? You click page 4. Click page 4. Click page 4. Right. What is this topic?
This is what angles.
I'll give you the formal name, Ken, because they sometimes use the formal name, Ken. So
Okay.
add bookmark, and I'll give you the formal name. Okay, add bookmark. Okay, page 4, right? So you're correct, right? Circle properties. Okay, circle properties. Okay, done so far, so good, right? Now, would you kindly go to the edit page mode? I want to test something. Go to edit page mode. Do you realize that page 5 and page 6 is also partial fraction? Would you please confirm that? If you can see that, good lah. If you don't, then please confirm. Page 5 and page 6. Well, I mean, if you cannot see, just click on page 5 and page 6. What to do? Just click on page 5. Page 6. Sorry. I mean, click on page 6 and 7. Okay, click on page 6. Is this partial fraction, and is 7 also partial fraction?
Yes.
All right. Then that means your organization is a bit off, right? Because your first page is partial fraction, right? But page 6 is also partial fraction. Don't you want to combine them? If that makes sense? Ainesh, can you hear me? Does that make sense?
Yes. So I put this in.
Correct. After page 1. How do you do that? You cannot do that here. You must go to edit pages. That's the most powerful page. Then just drag to after page 1, right? Okay. After page 2 also can. After page 2 also can. Now you're more organized, right? You're more organized. Now, my question is, does your bookmark change or not? That's my question. Remember, your bookmark was page 1 and page 4. Remember that?
Yes.
By shifting around, does your bookmark follow or not? It's important to follow. Does it follow?
Yes. Yeah.
Is that good or bad?
Good.
Good. And then your organization is great, because digitally, that's nice one. Physically, this is what is supposed to happen anyway, right? The bookmark won't be stuck at page 4, right? If you file something in front, the bookmark should go behind. That makes sense, right? That makes sense? Okay. So your organization should be at least until the level of bookmark. That means you can file things per topic. If this makes sense to you? Ainesh?
Sorry?
Your organization should be until the level of bookmark.
Yeah, it is.
Bookmarks per topic. So that means you can find at least per topic. If today you have partial fraction, you just add the pages behind the partial fraction, no? Or something like that. That will keep you very organized, enough organized near exam. If this makes sense, right? Anish, can you hear me? Okay. Today I have to ask you 2-3 times. Does it make sense to you?
Yeah, I can hear what you're saying. Yeah, so bookmarks. Bookmarks. So you want me to, like, from the future Jamboard, you want me to add to this and then.
Right. Okay. Then I have one more level to introduce you and Aditya. Okay. Let's go to page 3. Please go to page 3. What's the best way to go to page 3? Right. Sorry. Let's go to page 4. Sorry. Let's go to page 4. That's why. Okay. Right. Page 4. Okay. So page 4. Do you notice that this is the first time you talk about? No, this is not the first time you talk about improper fraction. Where is the first time you talk about improper fraction? How you don't have that? Where's your improper fraction page? Okay. Right. So like this. Instead, I'm going to ask you to do this, right? So I'm going to type a text here, right? So this text is something that you can add in your PDF, right? Say, for example, let me show you, right? Okay, go back to page 4, please. Go back to page 4. Now, Aditya and Ainesh, can you see that I type PF for partial fraction? No convenient x to sum. Okay, no convenient x to sum. Ainesh, do you understand what I typed? Because we did this like around 1.5 weeks ago.
Sure. No, I
This
don't.
is-
Honestly, I can't immediately recognize what you're trying to say.
Then read the example. You cannot just, it's impossible for you just forget everything. Read the example in this one. This is a question where you find it difficult because of this. Do you remember the difficulty back then?
Oh yeah, because I didn't have a common X bracket, right? Yeah.
Correct. Now, this is my proposed phrase. That's not a good phrase for you. Can you suggest a phrase that you will understand better? You meaning a future you, you know, 3 weeks, 2 weeks before exam. What is a better phrase to explain this difficult question to yourself in the future? Just to confirm, Aditya and Kakak Brian following it.
Yeah.
Right. So Aditya and Kakak Brian, we already cover how to combine PDF and how to reorganize PDF and how to add bookmarks. Those are the most basic thing about organization. I'm adding one more level, which is to tag. Tagging means we add our own text to search. Ainesh, what is a better phrase for you, future you?
No, I think I understand. There are no common X's.
So would you like to use my phrase or would you like to modify it a little bit?
Yeah, I don't know using a phrase, but how do I put this? Oh wait, how do you put the text?
Oh, that's annotation. So annotation is not what I want you to do. Now I will teach you something new. I'll teach you something new. How do you add your own text into this PDF? That's really gonna make your life very easy if you get used to it. Now, don't do edit pages. Now you do edit. You're gonna do edit. Go edit. Go edit. Not edit page, edit. Yeah, okay. Edit. Then what you want is text box. You want text box. Click. Right, and then you choose your own color, whatever you want. You can make it bigger or smaller. No common factor X to use, right?
More.
That's a very good point. Okay, then you can make it bigger like that. Okay. Right. No, click on the text box. You can make it bigger or smaller one.
What's
Yeah.
going on?
No. That's not the right way to do it. No, that's not the right way to do it. Undo first. Try. No. That's not how it works. So try go advanced. Advance. No, it doesn't work. Right, it doesn't work. No. The third button on the top. This one. There you go. You can make it bigger. Right. So try again. Try typing again. Text box. Click type. Yeah. Type. Yep. Now, would you like to use a different color? You should use a consistent color for your tag. You can change it here.
I'll just use black.
Then you cannot differentiate between my typing and your typing. That's not good. No, that's not good. Just choose a color for now. Yep, there you go. Style. Yeah. Just use a color for now. Okay, can use blue and dark blue, maybe. Dark blue, yeah, purple, yeah, purple, nice. Right. No common factor X to use, right? So now go to this is a tag. Let's call this a tag. Okay. Every time I say Aditya, Ainesh, tag your Jamboard. This is what I mean. Tag it, because all this writing from the Jamboard cannot be searched. They are just images. This is the unfortunate thing about PDF. But your own tag, you can search next time. You can, right? So let's pretend. Let's go to page 7. Please go to page 7. Let's go to page 7. And then you have 2 ways to search your tag. First thing first, use this one. Use this one. Use this thing. Use this thing. Do you see that your tag appears there? Annotation.
Yeah.
So this is the first way to go back to that. Okay. For example, I say, hey, Ainesh, we covered this question before, 2 weeks before exam. This is the no common X one. How do you find it? You go to, close. Don't navigate like that. Close. Go to outline, make it top. Go to outline, make it top. And then you search in your annotation. Oh, this is the page. You click that, and then it'll take you to that page. Okay, then I'll say, hey, see, Ainesh, you can revise this page. You can revise this question from this page, something like that. Make your life easier. Make sense?
Yeah.
Right. The second way to do it is, again, you go to page 7. We pretend that we are lost. You go to page 7. Right. Close the annotation. Close. Just close it. Okay. The other way is to simply search. There's a search button there. So, search. And then you have to recall your own tag, like common. Click, enter. Nothing happened, really? Really, what's going on here, right? What's going on here? The search doesn't work. That's so weird. Okay, I'm going to check what's wrong with the search button, but for now, this is organization, right? Okay, let's not troubleshoot here. Right? So Ainesh and Aditya, do you understand what I would like you to try every time after tuition? Ainesh?
Yeah.
Right. So after tuition, next time, I'll say, okay, Ainesh, time to organize. Spend 3 minutes doing this. Blah, 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 blah. Okay, organize, type. Okay. Aditya, what do you think?
I think I'm pretty sure it's the same. Like my bio teacher used to use what's this called?
Physical paper.
No. Jamboard. Yes, Jamboard. Sorry.
Right.
We used to use Jamboard to make notes for us, and then we would join a Google Meet and copy them. And then at the end of the year, because she left the school, so I think she used the same software to like arrange her notes and put it on the Google Classroom first.
You mean he uses Jamboard or he uses Zodo? What do you mean?
No, she used to use Jamboard, and then
Yeah.
after she used that software to like put it together for us, all like the full year's note,
Right.
because she left the school.
So you're saying that she must use something else besides Jamboard, lah, correct?
Yeah, so that like we can access it.
Correct. Because
So she
Jamboard
taught us how
has
to
its
use
own.
it as well.
Correct. You now understand that Jamboard has its own limitation, lah.
Yeah,
The worst limitation is you cannot search between Jamboard. That's the worst thing ever.
and then there's only like 20 pages.
Correct. Then you cannot grow your Jamboard because Jamboard is
Yeah.
meant to be like a whiteboard, lah, to be fair, lah. So what we are doing today overcomes that limitation, which is going to be very helpful near exam, lah, right?
Yeah.
Right. So if you understand what I'm asking you to do, then please do that after every tuition from now on. Then maybe your future self will definitely thank you, right? Whereas for your physical note, that's totally up to you, right? I think it's gonna be.
I think I'd rather use this than write everything down again.
I would
like,
definitely think. Yeah.
I've only done like quadratic equations up till now, and it's
Correct. Like
it's
why
so much.
bother, right? Correct. Why bother, right? What we want is
Yeah.
to search, not to redo, right? Sometimes that's
Yeah.
what we want, right? So we're being pragmatic here. So Ainesh, Aditya, I hope you get the idea. We'll start practicing this next time, lah. Okay.
Okay.
Right. So for today, I hope, even though we're not talking any topic, I hope it was very useful. And okay, let's try to do it for Ainesh tomorrow, lah. Okay, Ainesh tomorrow. For Aditya, we'll start doing this on Thursday, lah. Okay.
All right. Yeah.
So Aditya, you stay for a while. I need to get some updates from you. Ainesh, take a rest. I'll see you tomorrow. Right.
All right, see you. Bye.
Bye. Kakak Brian also stay for a while. Right. So Aditya, very quick update. So you tell me what's happening in school. Right. School has just started this week, is it?
Last week.
Last week. Okay. Then tell me what's happening in math.
So in AMath, currently we're doing permutations and combinations.
Oh wow. Right. Okay.
Honestly,
right,
it's like currently it's super easy.
okay. That's
Like
gonna grow.
it's just
very
like
quick.
press calculator and stuff.
Correct. But that tends to grow out of control after a while. Okay. Understand. So besides PNC, what happened before PNC?
Sorry, your voice is
Oh,
breaking.
sorry. So what's happening before PNC?
Nothing happened before that. Like that's the first topic.
All right. Then what's happening after PNC?
They haven't confirmed the scheme of work yet. So
Yeah. Understand. Okay.
like
So no news on
Um,
differentiation yet, lah.
yeah, no on that yet.
Right.
As soon as I get the scheme of work, I'll send it to you.
Sure thing. So nothing urgent in math right now, lah. That's what you're saying, lah.
Yeah.
Understand. So it's good that we can discuss organization, and even I think on Thursday, or maybe you should start practicing right now. Do you know how to get the Sodo app?
Yeah.
Right. You just go to Windows Store. You're using a Windows laptop, right?
No, I'm using Mac.
Okay. For Mac, I have no idea what to recommend, but Mac users should know. You should have a PDF editor which can shift pages, add bookmark. That's what you've shown, as you have seen today. You understand? You need that. I don't think Sodo exists in Mac, but if I'm wrong, I'm very happy, lah. Okay, I hope that it exists, but I don't think so.
I'm pretty sure it does. Oh no, it doesn't. No.
Yeah. But there should be a lot of other PDF editor which can do the task of adding pages and editing pages. That's like the most important function. And surprisingly, the basic PDF editor of Mac cannot do that. I'm very surprised that it cannot do that. I hope I'm wrong though. I'm not a Mac user. Right? So your first task is to find a PDF editor that you can use. That's your first. Then we can arrange our life digitally. Then future you, hopefully, will thank you lah. Right.
Okay.
Right. That's it. I'll see you on Thursday.
All right, then see you.
Bye-bye.
If I find an app, I think we can do annotate with Kami. Like I'm pretty sure.
Annotate cannot arrange pages and add pages. It's very annoying.
Ooh.
Annotate cannot. But if I'm proven wrong, I'm happy. Just try lah. I have to leave that to you. I'm not.
But it's not like an app. It's just an extension on Google Chrome.
somehow find something that works for you, somehow. Right?
Okay. Yeah.
Your future, you should thank you for this. You should. Okay, right? So
Yeah.
find that, and I'll see you on Thursday.
Okay. See you.
Bye.
Bye bye.
So Kakak Brian, very quickly. Sorry, I think I overshoot your 45 minutes. You see how I demonstrate adding pages, right? That's the most important primary function of the Sodo app, right?
Yeah, guy, your voice a bit soft.
That is it.
Hey, now it's better. It's okay.
All right. Okay. So you see that I was adding pages and then shifting around pages with iNet, right?
Yeah.
Right. I think it makes sense to call that's our first digital filing. That's how you should file things, correct?
Yeah.
Second level, add bookmark, right? Bookmark also easy to find so that you can fix a certain section. And then the third level is the one that you add text and tagging. So I just call that tagging. So tagging will make your search more detailed when you need them to be.
Mm.
So those are the three things that I want to introduce in any PDF editor in any organization that our student do. So besides making the Jamboard tidy in itself, which is what I introduced to you last time, then go to PDF, make it searchable. Then when exam, we don't have to hunt around stuff. That's why.
Right. Guy, your voice cannot hear
Again,
you.
all right,
Sorry.
again. Sorry.
The pickup is quite bad. The mic pickup.
Yeah.
Right. Are you speaking? All right.
Hello. Hello.
Just give Philip a while. I think he's gone. Like the Zoom is like down for him.
Oh, all right.
Yeah, I told him that you're here already, so he's trying to fix it.
All right. Thanks.
No problem.